Assalamualaikum and good day everyone. So today we are going to continue with the last chapter of AM015, which is chapter 9, application of differentiation. So for this chapter we are going to have 4 lectures, which is the first one we are going to focus on the subtopic 9.1, which is the tangent and normal equations. Okay, so for this lecture, the learning outcomes at the end of the lesson, students should be able to find the gradient of tangent and normal at a point on a curve, and then to find the equation, okay, the equation of the tangent and normal to the curve. So tangent and normal line. So you might have heard this term or might not. But this tangent and normal line is a standard way to classify a curve. Okay, let's say consider a point A on the given curve. This curve can be any type of function. Okay, so let's say this is our curve. We don't know what type of curve here, but it's a curve. So we have one point A on the curve itself. The line that touches the curve at A without crossing the other side of the curve is called tangent. So this is the important word here. It cross or it touch A, only touch A without crossing the other side of the curve. So the line only touch at A and go on. Okay, it calls as tangent, while the line perpendicular to the tangent A is called normal. So if we have the tangent, then the other line that perpendicular means that the degree between the tangent line and normal line is 90 degree. Okay, so this is our tangent line because it touch only once at A for the curve. It touch the curve only once, which is at A. And then we have the normal, which is the 90 degree to the tangent. So this is our normal. So the relation between tangent and normal is the degree. So we learn about the 90 degree between two lines in high school. What is it? So for the student with at maths might see this thing. M1 multiply M2 equal to negative 1. Okay, so this concept or properties is really important. Really important to use in finding the tangent and normal. Okay, gradient of a slope define the direction of the line is straight or curve. The gradient of the curve at A is the same as the gradient of the tangent to the curve A. Okay, so we have this curve. So to find the gradient of this curve at a certain point is the same as to find the gradient of the tangent. If the gradient of the tangent is m, then the gradient of normal line is negative 1 over m. How do we get? This is like the thing that I said earlier. M, let's say m tangent multiply with m of a normal, it should be equal to negative 1. This property is the property that we use to find the gradient of normal. So if the gradient of normal is equal to negative 1 over gradient of tangent. That's why if gradient of tangent equal to m, then the gradient of normal will be negative 1 over m. F prime x equal to dy dx is the gradient of y equal to fx. Okay, so to find the gradient at a certain point, we need at a certain point of curve y, we need to differentiate y. Why? because we will get dy dx, which is the gradient of the tangent. Okay, so if we get dy dx in terms of x and y, then means that we just have to substitute the point at the point. So because we have the point A, right? So we will have the x and y coordinate there. We just have to substitute into the dy dx that we found. Okay, so let's see some example. Okay, so before we continue with the example, let's see about the equation of the tangent and normal lines. So at the point of xy on the curve y equal to fx, so let's say we have this point A, which is xy coordinate. The equation of the tangent is equal to y minus y1 equal to mt multiplied with x minus x1. So this is the method to write down the equation of tangent. Why mana y1? Because, yes, we know the way to find the equation of a straight line, right? So this is another method to find the equation of a straight line. It's either y equal to mx plus c or y minus y1 equal to mt multiplied by x minus x1. So you can use either one. Okay, but because we know already what is the y and y1, so let's say x1 y1 is the point A here, x1 y1, so we can just substitute the x1 y1 and the value of gradient of the tangent. Okay, the equation of the normal is y minus y1 equal to mn multiplied by x minus x1. So the normal, this is tangent line, the normal line will be crossing the same point A. So the same point A, x1, y1, that's why we will have y minus y1 equal to gradient of normal multiplied by x minus x1. The difference between equation of tangent and normal is the m, the gradient. Okay, so let's see some example 1. Find the equation of the tangent to the curve y equal to x squared plus 2x plus 2 at a point 1, 5. Okay, so we want to find, what is the most important thing here? We want to find the equation of the tangent. Okay, so to find the equation of the tangent, what we need to do? We need to know what is gradient of the tangent, mt. And then we also need to know what is the point we need to use. So if we find the gradient, we can find the equation by using y minus y1 equal to mt multiplied by x minus x1. So to find the mt, to find the equation, we need to know what is our point A. So our point A here is equal to 1, 5. Means that our x1 equal to 1, our y1 equal to 5. Okay, so the first step is to find the gradient. So to find the gradient, we need to find the derivative of y, of the curve itself. So dy dx is equal to, so because differentiate y respect to x is equal to, directly equal to 2x plus 2. So this one we apply direct the basic formula. It's not an implicit, okay, directly. So now because we want to find the gradient at the point 1, 5, then we just substitute the value x and y into the dy dx. So now because we have only x, so just substitute x. So we have 2 multiplied by 1 plus 2 equal to 4. So the gradient here is equal to 4. So we done with the finding the gradient. Now to find the equation. So to find the equation, we need to use the formula y minus y1 equal to mt multiplied with x minus x1. Okay? So we have the mt already. We know already what is x1, y1. So we just substitute the value lah. So we get y minus 5 equal to 4 multiplied by x minus 1. And then simplify everything here. This one we get 4x minus 4. So y, the equation of the tangent, y is equal to, we bring the negative 5 to the right side will be positive 5. So y equal to 4x plus 1. So this is our equation of tangent. Okay? So example 2. Find the equation of normal to the curve y equal to x squared at point 2, 4. So now we have point here, point A here is x1, y1. And then we want to find the gradient of normal. Okay, first step is to find the gradient of normal, mn. The second step to find the equation by using y minus y1 equal to mn of x minus x1. You don't have to find the equation of tangent for this one. So, first step, to find the equation, to find the gradient of normal, we need to find the dy dx first, which is equal to differentiate y respect to x, dapat dy dx, differentiate x squared, dapat 2x. Now, at point 24, we get 2 multiplied by 2. 2 multiplied by the value of x, which is equal to 2, equal to 4. Now, this is the gradient of tangent. To find the gradient of normal is equal to negative 1 over gradient of tangent, which is negative 1 over 4. Okay, because mn is equal to negative 1 over mt. So now we have the gradient already. We have to find the equation of the, not tangent, but normal, yeah? Equation of normal. So, by using the formula y minus y1 equal to mn multiplied by x minus x1, just replace the y1, the mn, and x1. So, y1 is equal to 4, mn equal to negative 1 over 4, and x1 equal to 2. So, simplify everything, we get y equal to negative 1 over 4x plus 9 over 2. So, expand here, expand. So, we get negative 1 over 4x plus 1 over 2. So, that's why if we bring negative 4 to the right side, it will be positive 4. So, 4 plus 1 over 2 will be 8 over 2 plus 1 over 2, we get 9 over 2. So, this is the equation of normal. Okay, the question asks you for the equation of normal. So, the different step between equation of tangent and equation of normal, that is, yes, we just have to continue to find the gradient of normal. Okay, we get the gradient of tangent first, then we have to find the gradient of normal. That is only the additional step for the equation of normal compared to equation of tangent. Okay, now find the coordinate of the point on the curve y equal to 2x cubed minus 3x squared minus 8x plus 7 where the gradient is 4. Hence, find the equation of the tangent at its point. Okay, now we have the gradient equal to 4. What it means by gradient equal to 4? Means that the dy dx is equal to 4. So we want to find the gradient, the points where the gradient is equal to 4 means that the point A. A here is x1, y1. Okay, so what is dy dx? We don't know what dy dx, but we know what is y. So from y to find dy dx, it's equal to 6x cubed, 6x squared minus 6x minus 8. So this 6x squared minus 6x minus 8 is equal to 4. We compare dy dx with the value given here, which is the gradient equal to 4. Now to solve this quadratic, the right side should be equal to 0. So we need to bring 4 to the left side, we get negative 12 lah. And then simplify, we get x squared minus x minus 2 equal to 0. So because this point can be any more than one point, the coordinate of the points here, points more than one point, that's why we will have two value of x. So factorize x squared minus x minus 2, we will get x minus 2 multiplied by x plus 1 equal to 0. So the x coordinate can be x equal to 2 and x equal to negative 1. So this is only the x coordinate. How about the y coordinates? So the y coordinate, we just have to substitute into the function y. So when x equal to 2, y equal to 2 of 2 cubed minus 3 of 2 squared minus 8 of 2 plus 7. So we get y coordinate equal to -5. And when x equal to -1, y equal to 2 of -1 cubed minus 3 of -1 squared minus 8 of -1 plus 7, where it's equal to 10. So we have a point of 2, -5 and -1, 10. So on both this point, the gradient will be 4. Okay. And then the next part of the question. Find the equation of tangent and at these 2 points. So because we know already the gradient, so directly we can just substitute the value of y1 and x1. Okay, because the gradient we know already is given in the equation, the gradient is equal to 4. Gradient of the tangent equal to 4. So substitute y1, mt and x1, we get y minus -5 equal to 4 of x minus 2. So y equal to 4x minus 13. Okay, this is for point 2, -5. So the equation of tangent for point at -1, 10, we replace the y1 with 10 and x1 with -1. So we get y minus 10 equal to 4 of x minus -1. So we have y equal to 4x plus 14. Okay? Okay, so now we have the equation of tangent already. So last example ke? No. Example 4. Find the equation of tangent and normal to the curve x squared plus y squared minus 5x plus 4y plus 6 equal to 0 at point 2, -4. So 2x, so we differentiate each of these because we cannot separate the equation into explicit form. We need to differentiate it directly by using the implicit differentiation. That's why we need to differentiate each of these terms. To differentiate 2x squared, we get 2x. But to differentiate y squared, we get 2y dy dx. And then differentiate -5x, we get -5. Differentiate 4y, we get 4 of dy dx. And differentiate 6 will be 0, equal to 0. Now group the dy dx together. Okay, what we have is dy dx. We take out the dy dx, so left in the bracket is 2y plus 4. And the right side we have 5 minus 2x. So dy dx is equal to 5 minus 2x divided by 2y plus 4. So to find the gradient of a tangent and normal, first we need to find the gradient of the tangent. We just have to substitute x1 and y1. So we have dy dx equal to 5 minus 2 of 2 divided by 2 of -4 plus 4. Okay, so now we have the value of dy dx, which is the gradient of the tangent equal to -1/4. So how about the gradient of the normal? So it will be the negative of 1 over -1/4, which is equal to 4. So now we have both gradient for tangent and normal. We can substitute the value into the equation form. So to find the equation of tangent, so it will be y minus y1 equal to m tangent multiplied by x of minus x1. So y1 is equal to -4, x1 equal to 2. So and m1 equal to mt equal to -1/4. So we have y minus -4 equal to -1/4 of x minus 2. So simplify everything. Here we can expand. We get -1/4x plus 1/2. And then minus 4 will be -7/2. So y equal to -1/4x minus 7/2. Another way to write down this, we can simplify by multiply by 4 everything. Okay, so that's why we have 4y equal to -x minus 14. But here x also we can bring it to the right side. So 4y plus x equal to -14. So we have many ways to write down this equation. So if it's a MCQ question, so you have to look at which method or which form there, write down the equation. So just simplify everything lah. So you can rearrange everything to see how it look like. Okay, so for equation of normal, y minus y1 equal to mn of x minus x1. So y1 is negative 4. Equation gradient of normal is 4 and value of x1 is equal to 2. So what we have here is y plus 4 equal to 4x minus 8. So y equal to 4x minus 12. So this is the equation of normal. This is the equation of tangent. So done. So example 5. The curve x plus xy plus y squared equal to 2 intercepts x-axis at A. What it means by this curve intercept at x-axis at A. So where is x-axis? Is the horizontal. So this curve will intercept at x-axis at A. So what is A? A is the x-coordinate lah. X-coordinate. But what is the value of y? At x-axis, the value of y will be 0, right? This is the value of y. Y is 0. So we know we have the point x0 here. So that is how we analyze the question first. The question here is to find the equation of tangent and normal. First of all, we need to know what is this point. We know already y equal to 0, means that we can find the value of x by substituting y equal to 0. Okay, so y equal to 0, x plus x of 0 plus 0 squared equal to 2. So x equal to 2. So the coordinate here is 2, 0. So we can find the gradient MT, gradient of the tangent and gradient of the normal, because we know already what is the value of x and y. So differentiate the function first, the curve first. So we differentiate x, we get 1. And then differentiate xy, this is multiplication between x and y. So we have to use the product rule. So u equal to x, v equal to y. So u prime equal to 1, v prime equal to dy dx. So it will be v u prime plus u v prime. So y multiplied by 1 plus x multiplied by dy dx. And differentiate y squared, we get 2y dy dx. So now group together the dy dx. So we have x plus 2y of dy dx equal to negative y minus 1 or negative 1 minus y. So dy dx is equal to negative 1 minus y divided by x plus 2y. So now at point, we know already, we found already the point which is 2, 0. We substitute the value 2 and 0 into the equation. So we get negative 1 minus 0 divided by 2 plus 2 of 0. So negative 1 over 2 is the gradient of the tangent. So the gradient of normal will be 2. Okay, so we can find the equation of the tangent and normal because we know already the gradient. So equation of the tangent will be y minus y1 equal to m tangent multiplied by x minus x1. So y1 is equal to 0, x1 equal to 2, mt is equal to negative 1 over 2. So we get y equal to negative 1 over 2x plus 1. Expand, expand. And then equation of normal will be y minus y, which is 0, equal to the gradient of normal, which is equal to 2 multiplied by x minus the x coordinate, which is equal to 2. So y is equal to 2x minus 4. This is the gradient of normal. Simple, right? Okay, so we just have to apply the differentiation to get the gradient. That's all. We get the dy dx in terms of x and y. Just replace the x and y with the coordinates. That's all. So mt is equal to directly dy dx, and then the gradient of normal is negative 1 over the gradient of tangent. Okay. That's all for this lecture. I hope you can continue with the tutorial for chapter 9. Thank you.